Now, this is lesson 3.3. What's the goal? We need to learn about function notation. Our key question is, how can I use function notation to represent a function? Remember, we are taking into account real life situations, but we are using mathematics to represent them. In other words, we can use the word model. How can we model those situations and interpret and understand what is going on using our mathematics? How will you know that you understand this topic of function notation? Well, this is the success criteria. You will know how to use function notation to evaluate and interpret functions. You will also say, well, I know how to use function notation to solve and graph functions. And I can use function notation to solve real life problems. So let's begin. One important thing you need to understand in terms of the concept and what it means, what does that mean? Function notation is every time you see the y in the form of y equals mx plus b, which is the linear function, that's what we call the standard form whenever you see the letter or variable y. But we can also see what we call function notation, where instead of you seeing the letter y, we are going to substitute it by the term f of x. Okay, and this is really important. So y transforms into something we call f of x. Remember, there was a video before when it doesn't necessarily mean that you are forced to use f of x every time. You can use g of x, for example. You can use the variable in the input. You can say h of t. As long as you see something like this, a letter indicating the output, and what's inside the parenthesis indicates the input. This f, g, and h are kind of like the name of the function, and what's inside x, or t are the input, or it also represents, remember, the independent variable. Understanding that, in this case, the function depends on x or depends on t for its output values. Okay, so now we're going to look at how we can evaluate functions using function notation. So here we are. We have the function f of x, in other words, y, equals negative 4 times x plus 7. What is the meaning of this? So, if you imagine the machine, remember the machine we had at the beginning? We have this, something like that, right? So we have the function which does or carries out or performs some operation as you enter something here. We drop the input here, then the machine does something, and then boop, you got the output, all right? Okay, so here's the output. The function f of x is the way that you interact mathematically, the input with certain operations to produce something. Well, in this case, we need to evaluate the function when x equals 2 and x equals 3. In other words, our inputs are going to be, what are you going to put here or enter here? Well, it's simple. We're going to enter two numbers. We're going to enter number 2 first, and then in the second place, we're going to enter number negative 3. I want to know what the output is once I do that. So in the first place, when x equals 2, and pay attention to this, it means when x equals 2. It means that I want to evaluate the function. So the function, the output, when x is 2. As you can see, I just substituted the x for that 2. So it equals negative 4 is going to multiply the number we are currently using for our input, which is number 2, right? Not negative 2, number 2. And then you add 7. So f of 2, f of 2 means what is the output when the input is 2. we're just going to perform the operations based on PEMDAS. Remember, order of operations, multiplication and addition. It means multiplication goes first. You're going to perform this multiplication first. Negative 4 times 8, sorry, negative 4 times 2 is negative 8. And then there's a plus 7 right here. So conclusion, the function or the output for the input of 2, it's going to be negative 1. Okay? That's how you should read it. Okay? In the first place, you need to understand it this way. When the input is 2, the output is negative 1. Hope that's clear. Now I'm going to erase because now I'm going to do the second part of our exercise. What is it? Now I want to know what the output is when the input is negative 3. And as you can see, it's going to be kind of like the same way, but this time the input is going to be a negative 3. Actually, I can do this. Look at that. I can kind of like just do some erase in here, and I'm going to change the color. So when x equals negative 3, so I'm going to substitute it here because now the input is negative 3, which means that right here we have negative 4 times negative 3, and then you do plus 7, right? Okay, so let's keep going. So when the input is negative 3, this is what happens. Again, we do the multiplication first. Negative 4 times negative 3, it's going to be 12, plus this 7 coming from here, remember? And then 12 plus 7 is 19. So I want to write this for you because I want you to understand it very clearly. When the input is negative 3, the output is 19. Okay, hope it works.